Hello everybody! So today we're going to be talking about the difference between a linear and an exponential model. Now when we say we're creating a model, what we really mean is that we're representing a real world situation. So when we say we're creating a model, what we mean is that it literally represents something from the real world, like a model airplane would represent a real airplane. There are two different models that we're going to talk about today, one of which we've learned before and one that's kind of new related to our new topics. So the first one we're going to talk about is our review model, which is about linear. When something has linear growth, what that means is that the same amount is being added or subtracted to your initial amount over a certain time period. So the general form of this function would be y equals mx plus b, where m is the slope and it repeats in the problem multiple times, and the b is the initial value, and that's a one-time amount. Hopefully this sounds familiar because it is something that we've actually learned before. And an example of linear growth would be you start with $50 and you earn an additional $100 every day at work. The reason we would call this linear is because you are adding the same amount every time. So we would say that this is an adding pattern, and therefore it would be linear growth. So we would write y equals mx plus b, and we would need to identify the m and identify the b from the problem. Now the m is what repeats over and over again. So because I'm earning $100 every day, that would be the m. And because I started with $50, that would be the b. It's your one-time initial amount. I should probably include the word initial there. So when we set this up and we create an equation, we would have y equals 100 instead of m, x plus 50 because you started with $50. Now this is all kind of a review. This side of the paper where we're talking about exponential models is our new idea. When something has exponential growth, it means the same amount is being multiplied or divided from your initial amount over a certain time period. So in general, and when we write these equations, it doesn't look like this because that would be linear. It looks like this. Y equals a times b to the x power. Now in this problem, the a is the initial amount. It's a one-time thing. It's how much you start with. Just like the green b here was the initial amount, the green a here is the initial amount. The b is the multiplication or division pattern that you're following. So this is the amount being multiplied or divided. And this is going to repeat over and over again, just like our slope here repeats over and over again. And in this problem, the x is actually the exponent. So it's not multiplied by the b is actually being raised to that power. So for example, if you start with $1 and every day after that you double the amount of money you have, when I see the word double, that means multiply by 2. So I would call this a multiplication pattern, which means I know that it's exponential growth. So what I would do here is I would write y equals a times b to the x power, and my job is going to be to identify the a and the b in the problem. Now the a is however much you start with, your initial amount. So the $1 is going to be your a. And b is the amount that you're multiplying or dividing by. So because we're multiplying or dividing by 2 this time, b would be 2. When I fill that into my problem, I would have y equals 1 times b, which is 2, to the x power. So let's take a look at some example problems. The first thing that we're going to have to do in each of these examples is determine whether we have exponential growth or linear. So in other words, whether we have a multiplying and dividing pattern or an adding and subtracting pattern. It says here a library has 8,000 books and is losing 3 books each year. Losing means subtracting. So this would be a linear pattern, and we would choose that because we have a subtracting pattern in the problem. Now, we need to define our variables and write an equation to model the situation. Because I'm counting the number of books, I would let b be the number of books. And because I'm decreasing the number of books each year, I would let x be the number of years. Now, when I put that together and I make an equation, since it's linear, my equation is going to be b equals mx plus b, where b is the number of books and x is the number of years. M is going to be however much is repeating, so it's happening over and over again. Since I'm losing 3 books each year, M is going to be -3. And B is however much you start with. So since I started with 8,000, I would say plus 8,000. So my equation would be B equals -3x plus 8,000. Now we're going to use our equation from part B to determine the number of books the library will have left after 10 years. Because this says 10 years, we know that that is an x value in this problem. So what I'm going to do is take this equation, B equals -3x plus 8,000, and I'm going to plug in 10 for my x, because that's the x I'm being asked to use in this part of the problem. And if I do that, I should get 7,970 books after 10 years. Now let's take a look at another example. So my next example says a bank account starts with $10 every month. The amount of money in the account is tripled every month. So because it says tripled here, that means multiplied by 3. So my pattern here would be a multiplication pattern. Which means I would choose an exponential model. Now I'm going to write an equation to model this situation and make sure to define my variables. Since I'm measuring the amount of money in an account, I'm going to let M be the amount of money that I have. Since that money is going to increase every month, I'm going to let X be the number of months. Now, because this is an exponential model, I would write M equals A times B to the X as sort of my basic equation. And now I need to figure out my A and my B. Now my A is going to be my initial amount. So my initial amount here is $10. B is going to be whatever my pattern is, however much I'm multiplying or dividing by. So B is going to be 3, which means my equation, when I fill in those numbers, will be 10 times 3 to the x power. Now part C says use your equation from part B to find the amount of money that you would have after 6 months. And in this problem, the x values are the months. So what I'm going to do is take this equation that I wrote, and I'm going to replace the x with a 6. Now, I don't know this off the top of my head, so I'm going to go ahead and type that into my calculator. 10 times 3 to the 6th power, and I get $7,290 in my account after 6 months. Now, you'll notice in the last two problems, I gave a label, books and dollars, to my final answer. So it's going to be really important that you put labels on your answers in these problems. Number 3, it says there are 20,000 owls in the wild. Every decade, the number of owls is halved. When I see the word halved, that means divided by 2. So this is going to be a division pattern. Since we have a division pattern, we're going to choose an exponential model to represent this situation. So now what we're going to do is define our variables and then write an equation. Since I'm counting the number of owls, I don't necessarily want to use the letter O because it looks like a 0. So I'm just going to call it Y this time and say that Y represents the number of owls. X this time is going to be a decade because it says that the number of owls changes every decade. Because this is an exponential model, my equation is going to be y equals a times b to the x power, where a is my initial amount, so 20,000 owls. And b is however much I'm multiplying by. Now, because it's a division problem this time, instead of putting a 2 as the base of my exponent, I'm going to put a 1/2. Because having a 1/2 is the same thing as dividing by 2. So now if we want to use our equation to determine the number of owls after 80 years, I would have y equals 20,000 times 1/2 to the x power. In this problem, 80 years would be 8 decades. Because remember, x is the number of decades, and a decade is 10 years. So what I'm going to do now is plug in the number 8 for my x value. And again, I'm going to type this in on my calculator. And I get 78.125 as my final answer. Now, since I'm counting the number of owls, I would give that a label of owls. Obviously, in the real world, it would be impossible to have 78.125 owls, but it means we're going to have around 78 owls left. All right, now when we're dealing specifically with growing and decaying by a percent, so sometimes we're going to have problems where we're changing by a percent. When you see the word percent, it does tell you that this is exponential, but it also tells you we need to set up the equation in a very specific way. So the formula for whenever we have growth where we have a percent looks like this: y equals c, parentheses 1 plus r to the t, or y equals c, parentheses 1 minus r to the t. The only difference between these two formulas is that one of them has a plus and one of them has a minus. We use the plus when we're dealing with exponential growth, so our numbers are getting bigger, and we use the minus, pardon the typo, for whenever we're dealing with exponential decay, so our numbers are getting smaller. Think about growing as increasing, and think about decaying as decreasing. So what do these things stand for? Well, once again, C is the initial amount. R is your rate or your percent that you're growing by, but you need to change it to a decimal. In other words, you need to make sure you convert that to a decimal before you actually use it in the problem. For example, 20% would convert to 0.20. T is just like an x. It's just a variable that we use and we might substitute things in for. Now these are the same in both problems. So let's take a look at number 1. A newly hatched catfish typically weighs about 6 grams. During the first weeks of life, its weight increases by about 10% each day. As soon as I see this percent and that it's increasing by a certain percent, I can choose to have an exponential model because I have a percent pattern. Now, because it's a percent pattern, I'm going to use the equation y equals c parentheses 1 plus r to the t power. And in this problem, y is going to be the amount that it weighs. And t is going to represent the number of days because it changes each day. So if I plug in my numbers, my initial value here is that it weighs 6 grams. My rates would be 10%, but 10% is really 0.10 as a decimal. And t would be my variable. Now I can actually simplify this by just combining the stuff that's inside the parentheses, and this would be my final answer. It says in part C, use your equation to figure out how much it would weigh after 10 days. So 10 days is a t value because t represents the number of days. So I would have y equals 6 parentheses 1.1 to the 10th. Again, I'm going to use my calculator. And I would get 15.56 grams, because in this problem I'm measuring my weight in grams. We're going to go ahead and save the last problem for tomorrow when you guys come to class. Thank you guys so much for watching. I appreciate it. Have a great afternoon.